Now, to get a handle on this interesting pattern of interpretation, let's see if we can apply the noisy channel theory that we've been developing. So just to give labels to parts of this process, we'll call the intended message M. There's a prior over that in the model. The intended message gives rise to an utterance U through a speaker likelihood. U is then potentially distorted through any of a variety of noise processes, and it gives rise to an input to language comprehension I, and then the problem of the comprehender is to back infer what M and U were likely to be. So we'll call the sentence that the comprehender is actually analyzing I, and we'll think of the value of M as being whatever's necessary or relevant for the comprehender to answer the question, was something baked for Lucy. So depending on the answer to the question that an experimental participant gives, we will take that to be an indication of what the comprehender concluded M was likely to be. Now, we're also interested in understanding this kind of process about what are the possible kinds of noise sources or noise operations that apply in the process of language comprehension and language production, or as language production as is modeled in the mind of the comprehender. And what I want to point your attention to is that in this example, there are two semantically plausible quote-unquote neighbor sentences where the answer to this question will be yes. Once again, remember that if you take the sentence literally, the answer should be no. Nothing was baked for Lucy. The cook baked something for a cake. But of course, it's very likely to want to answer yes. And note that there are actually two small changes that one could make to this sentence that would render the answer to this question yes. So the first one is to imagine that actually there's a word missing, that word is for, and it occurs in between the words cake and Lucy. So if the cook baked a cake for Lucy, now the right answer to this question is yes. On this view, we can think of this possibility as the interpretation process, to say the sentence seems to have a word missing and I'm going to answer the sentence as if a word were missing. We'll call that the hypothesis of a noise operation that occurred. And that is a deletion. That is that M was something that should be expressed with the word for in between cake and Lucy. It would be naturally expressed as the cook baked a cake for Lucy. But the word for was left out in the process. And that is a hypothesized deletion operation on the sentence. The second possibility is that the order of cake and of a cake and Lucy was gotten wrong. That is that the intended form would be the cook baked Lucy a cake, but that the order of the words got messed up. That's a different kind of noise operation. That's an exchange. And so that's an alternative path to relating the utterance relating the input and the intended message. If one assumes either of these operations coming in between M and I, then it would account for, first of all, it would render the sentence more plausible. So it would increase the prior probability of the sentence, or of the meaning M. And it would also lead to a yes answer as a natural answer. So the idea here is that if once again, remember that in this kind of theory, crucially, the probability of the meaning given the input to comprehension should be reconciling jointly the likelihood and the prior. So the likelihood is P of I given M, the prior is P of M. In this case, as we saw last time with cases like the coach smiled at the player tossed the frisbee, we should predict a trade-off between likelihood and prior. So we can choose, we can suffer a little bit of the likelihood by interpreting a sentence as if it were a little different than it actually is, if we can get to something that is higher in prior probability. So the noisy channel theory will predict these kinds of yes answers to questions like this if we hypothesize that the noise operation inventory includes at least one of this kind of deletion or exchange. So let's see where we can go with that. So once again, so we have the crucial equation that the probability of m given I is the reconciliation of the likelihood I given m and the prior on m. So we can think of the likelihood as coming from the likelihood is not terribly low. If there are noise operations that are not incredibly low probability that would lead to the input sentence that we're analyzing, given this intended meaning that is not literally compatible with the input sentence, but is maybe compatible with an alternative sentence that's very close to it. And furthermore, it would have to be the case of the prior tie. So we can test this by doing an experiment with examples like we just saw, but a richer inventory of examples. And we'll see that depending on the hypothesis about the noise operation inventory that's in the mind of the comprehender, we'll get somewhat different predictions. So first of all, let's take these implausible double object or benefactive for alternations. So we have the cook, bake the cake, Lucy, that's a double object construction. And something that's very, very close to meaning the same thing would be the cook, baked Lucy for a cake. That's the benefactive for alternation with the double object construction. Notice that both of these are implausible sentences. They describe states of the world that, or events in the world that are a priori not likely to happen. Lucy usually does not get baked, and cakes don't get things baked for them. So regardless of we saw that both of these sentences are going to have, well, first we saw that the first sentence is going to have these two neighbors. One of them involves a hypothesized deletion, hypothesizing that the word for was after a cake and that it got deleted, or a hypothesized exchange, that a cake and Lucy were put in the wrong order. The second sentence, the cook baked Lucy for a cake, once again, an exchange hypothesis would lead to a yes answer to the question. A deletion hypothesis wouldn't. There's no way of introducing a single word and recovering the intended interpretation. But if we hypothesize that there was an insertion, that is, if the word for wasn't supposed to be there but was actually accidentally inserted, then we will get that interpretation. So on a model that will allow deletions and insertions, we would get a prediction of yes answers to the second example as well. We can contrast this with plausible examples. The cook baked Lucy a cake, the cook baked a cake for Lucy. In this case, although the noise operations would render these neighbor sentences that would lead to a no answer plausible or possible, the neighbor sentences are much less plausible than the actual sentences. So the prior is going to very strongly favor the actual sentences. And if we ask the question, did something get baked for Lucy? Of course, we would answer yes. And so that would not be a non-literal interpretation. We can also look at another kind of these things. So let's look at the active-passive alternation. Let's look at implausible actives and passives. The ball kicked the girl was kicked by the ball. In both of these cases, there's no way of hypothesizing the deletion or insertion of a single word that would lead to imagining a plausible underlying intended sentence that would be reconciled with the actual sentence. You can hypothesize insertions and deletions. In particular, you can imagine that was and by were both supposed to be there, and they were both accidentally left out. And in the second case, you can imagine that neither was nor by was supposed to be there, and they were both inserted. But that's even under a model in which individual noise operations of deletion or insertion are implausible. That would be quite an implausible constellation of events in the production and transmission process for both of those things to happen. So the deletion and insertion model would predict that these sentences are not likely to be misinterpreted in the same way that the sentences in the double object benefactive for construction are. On the other hand, for the exchange model, it's still very easy to hypothesize that the ball and the girl were put in the wrong place. And so it should be quite easy to, it's just a single noise operation of exchange, just like in the double object benefactive for alternations. So here we would predict, yes, that these will have a reasonable misinterpretation rate. In the implausible condition, of course, in the plausible condition, we should have a very low misinterpretation rate, non-literal interpretation. So Let's see what we get for these examples. So to remind you of the predictions of these theories we have on the top, for the double object prepositional object benefactives, both of the theories of the noise operation inventory predict that you will get a reasonable amount of non-literal interpretations. For the active passives, only the exchange theory predicts that you will get a reasonable amount of non-literal interpretations. Just to orient you to these graphs, on the x-axis in each of the panels, the first two columns are the implausible versions, the second two columns are the plausible versions, the last one is fillers, which are all in this study. They're plausible, grammatically fine sentences, and so we should have a very high proportion of literal responses. And the y-axis is proportion of literal responses. So for conditions in which there's a reasonable amount of non-literal interpretations, the bars will be low, but for the plausible conditions and for the fillers, the bars should be very high. So for the benefactives, let's see what happens. What we see is that for the plausible conditions and the fillers, we have extremely high literal interpretation rates. That is a good sanity check that our experiment is working well and we have a sort of a high signal experiment. But what's more crucial is that we see that there's actually a lot of misinterpretation, a lot of non-literal interpretation for the implausible conditions. And it's actually especially low for the double object, which we'll get to in a little bit. What about the situation for active passive? This is a little bit more of a litmus test between the two hypotheses about the inventory of noise operations. The insertion deletion hypothesis predicts that there will not be a lot of misinterpretation of these, so the bars should be very high. The exchange hypothesis predicts that there will be a reasonable amount of misinterpretation, the bars should be low. And what we see is the bars are actually quite high, so it seems that the insertion deletion hypothesis is doing a better job of predicting these data. So these are two examples. Actually, the Gibson et al. Paper looked at 5 different constructions. So the active passive and the DOPO benefactive are numbers 1 and 5. We just looked at that, but there are 3 others. And I'm only showing you the implausible version here. The plausible versions are totally recoverable from what you see on the page here. And the question answering accuracy is almost always follows a literal interpretation for the plausible cases. So I don't want to go into it here. One thing I do want to emphasize is that for, once again, as we talked earlier, the active passives would involve, under an insertion and deletion noise model, they would require 2 insertions or 2 deletions to get from an implausible to a hypothesized intended plausible. Likewise, this other one, the subject locative and object locative one, would require hypothesizing 1 insertion and 1 deletion. So for example, the table jumped onto a cat, you would have to assume under an insertion and deletion model that onto was inserted at that position after jumped and was deleted at the position after before the table, and vice versa for the onto the table jump, onto the cat jump to table example. For the transitive intransitive, we have things like the tax law benefited from the businessman. If we hypothesize that the word from was accidentally inserted, then we would have the tax law benefited the businessman as the intended meaning. And so that would be a non-literal interpretation. And then the DOPO goal examples are very similar to the benefactive ones. These are things like the mother gave the candle to the daughter, which is 4D. And if we imagine that the speaker intended to include the word to between candle and daughter, but left it out, then we get an interpretation which has the opposite thematic role assignment, and so we would get non-literal interpretation. In all these cases, examples C require an inferred insertion, and examples D require an inferred deletion, with the exception of example 2, which has 1 of each in both cases. That difference between C and B is actually important, and I'm going to get to it in a moment. So here are the results for these 5 experiments. First of all, you can see that there's this, these are arranged from the, once again, on the y-axis is the rate of literal interpretations. And you can see, as before, there are virtually no non-literal interpretations for the passive actives. There are also very few for these locative cases, which would require 2 insertions of deletions. For the transitive intransitives, we see actually a higher rate of misinterpretation, even higher rate for the goal examples, and the highest rate of all for the benefactors. Now, there are a couple of things that I want to draw your attention to. So one is this overall Klein, where the goal and the benefactives have the highest rate of misinterpretation. But the other thing I want to draw your attention to is that it's always the case that the D version, the one that would require hypothesizing a deletion, has a higher rate of misinterpretation, of non-literal interpretation, than the C version, which would require hypothesizing an insertion. So when you have to hypothesize an insertion, you're less likely to adopt a non-literal interpretation than when you have to hypothesize a deletion. And that's actually very interesting, and we're going to get back to that in a moment. But there were two other exciting and important things that this experiment did, which are pretty cool. So the first thing that they did is they did a version of the experiment where they had the filler materials. So in the base experiment, there were 20 experimental items, half of which were plausible, half of which were implausible, and then 60 plausible and grammatically normal fillers. So as a result, there were 80 trials, and only 10 of them had implausible. There were only 10 of them were implausible, and also actually only 10 of them had weird syntax under a plausible reading. There's another version in which they included a lot more fillers with syntactic errors, like a legislator lied to the consultant a new bill, or a bystander was the fireman rescued in the nick of time. So in this version of the experiment, they filled the study with a bunch of syntactic errors. Now, if you think about what that should do to the comprehension process, what it's basically saying is that the experimental participant is in an environment where they have lots of evidence, where actually the likelihood of a noise operation that distorts the input to something that is not necessarily plausible is much higher. So if comprehenders adapt to that kind of environment, as we would on a sort of overall rational view of the language understander, then we should expect that effectively what that's doing is it's upping the probability of I given M for noise operations that would lead to a plausible underlying intended message. And so what this should do in the syntactic error case is it should actually raise the rate of non-literal interpretations, and so all the bars should systematically go down. Once again, this is not a manipulation of the experimental items itself, it's a manipulation of the fillers. That is the environment in which the experimental items are situated. But if comprehenders are adapting, then they should actually have their baselines pushed around in that way, and we should see the bars go down in the second line. And that is exactly what we see. So, for example, it's maybe most obvious in the benefactive case, where in the base experimental condition, we had about just under 60%. In the prepositional object version, had literal interpretations. That's about 40% lower. It goes down from just under 60% to just over 30%. And you can see that the rate of literal interpretations is cut to it by a factor of more than 50% for the double object benefactives. And actually, all 5 of these conditions, you can see that the non-literal interpretation rate is going up because the bars are going down. The height of the bars is the literal interpretation rate. So that's one manipulation. They also did the opposite manipulation in some sense, which is they packed a whole bunch of implausible trials into the experiment. They did this by taking all 5 of these settings, whereas originally they had done 5 separate experiments, one for each of the 5 columns with the same fillers. In this many implausible trials, they just did one across the board experiment. So all of the experimental items were together, and so now you just have a higher rate of implausible trials overall. So it goes from 1/8 of the trials to over 1/4 of the trials. And so what this should do is it should downweight the plausibility, because it says we're in an environment now where implausible events are likely to be talked about because they're being talked about much more often. And so this should push the bars up, because we now should be basically much less inclined to use our ordinary prior expectations on messages to be conveyed to guide interpretation. And we should hew more closely to the actual input and the fine details of the input itself. And that's also what we see. So in this case, once again, it's maybe the most clear in the benefactive case that we went from just under 60% of literal interpretations to now 80% of literal interpretations for the prepositional object, and from about a little less than 30% to about 50% for the double object. So these are all predictions that are, these second and third rows of this table are really wonderful demonstrations of validated predictions of the noisy channel theory. Effectively, these manipulations of the environment in which individual experimental trials are situated is effectively dialing down either the likelihood in row 2 or the prior in row 3. And we get exactly the effects that we would predict. Now I want to come back